Well, this will be the last video that I make. We're going to do 3 problems here. This is the last factoring video that I will probably make, and this is whenever we have a difference of squares. So the difference of squares is whenever you have 2 terms. It's a difference, meaning subtracting. This does not work if this were a plus. It has to be subtracting. And the first term and the last term both have to be perfect squares. Now, if you look at this term, it's not a perfect square, neither is this one, but it's because there's probably a GCF here. So I always look for a GCF. By now you should know that. And I see that I do have a GCF, which is 5. So I'm going to factor that out. And I'm left with x squared minus 4y squared. Now the 5 comes along for the ride, but inside the parentheses I have that difference, and now I have my 2 perfect squares. And so as soon as I know that I have a difference of squares, I do 2 parentheses, and it's always 1 positive and 1 negative for my signs. And then I simply take the square root of my first term, which in this case is x, and the square root of my second term, which is 2y. And that is my answer. In number 2, my GCF is a 4, and I'm left with the quantity x to the 4th minus 9y to the 4th. Whoops. So I keep my 4. I notice that I have a difference of squares, and so that's x to the 2nd plus and x to the 2nd minus, and then we get 3y squared as the square root of the second term. Okay, so no big deal. It's called a difference of squares that we're factoring. Alright, let's see here. We have one more we're going to look at. This time we have 2 as a GCF. We're left with u to the 6th minus 4v to the 6th. Keep the 2 sets of parentheses, 1 of each sign. Take the square roots, which are u cubed and 2v cubed, and we're finished right there. Okay. Alright, let's do one more problem here. I'm going to make this one up. We're going to say we have p to the 4th minus p to the 8th. Okay. The reason I want to do this is because it's something that happens that's interesting with these difference of squares. So let's go ahead and factor the, and I shouldn't have put p to the 8th. Let's say p to the 4th minus, let's pick a different letter. Let's pick r to the 8th. Okay, so let's go ahead and do this. Difference of squares means 2 sets of parentheses. We have p squared plus r to the 4th and p squared minus r to the 4th. Okay. Now the first set of parentheses, or the first quantity, has a plus in between the 2 terms, and so if there's not a GCF, it's already factored completely. But the second set of parentheses I see is a difference of squares, so I'm going to factor further and say that I have p plus r squared and p minus r squared. Okay, so my point is that occasionally as you're factoring these difference of squares, you might continue to get a difference of squares, and you might have to factor again. So you may have to factor multiple times. It's key to remember that when you're factoring a difference of squares, that you're looking for a subtraction sign with 2 terms, and each of those terms must be a perfect square. Always look for a GCF first, and you'll be good to go.